there, this is video 19 on finance, and it is kind of the first round of practicing compound interest solving for the accrued amount. So this is taking all the stuff that we've learned so far, practicing the formula, the I's, the N's, all of that stuff, and some of the translation, and putting it into practice. Okay, so handy dandy. That's the amount I started with. Here we've got our time. Here we've got the percent, we've got our years, and now we also need to watch for the compounded part. If it's compound interest, somewhere in the question it should say compounded annually, compounded semi-annually, compounded something or other. If not, odds are I made a mistake in the question because it should be there. All right, so A, P, I, and N. I'm going to start with my years, 10 years. Oh, wait a minute, times annually, 1. I know that's kind of a waste of time, but you know what? If you do it every single time, it's going to make life a lot better. Just get in a habit, multiply all the time. So my interest is 3.8 divided by 100. Again, divide by 1, just annually, 0.038. And she invested, well, she invested in money, so that's 4,300. See, we don't know what she had. We do know it should be higher than 4,300. So A is P1 plus I to the N. So different formula this time. I almost wrote the other one. So be careful, you got to pay attention. And how do you know? Well, 1, because we're doing the section on compound interest, but you just look for, literally look for the word either compounded or simple. Simple interest, going to give you that one formula. Compounded could be compounded. It could be a compound question, it could be an annuity question, or it could be a loan question. So it's kind of like the simple interest is in its own category. Anyway, back to the question. A is equal to 4,300. 1 plus, now my interest, 0.038, and it's compounded over 10 years. So A is equal to 4,300, 1.038 to the 10. So add together first. Now we worry about our exponent. .038 exponent 10, 1.452, and then I multiply by 4,300. All right, so it's 6,243. Oh, that's fun. All right, 699. So this 9 makes that go to a 10, which makes that go up. So it's actually 70 cents. And there we go. And that makes sense. She started with $4,300 and now she's got $6,243.70. I think you should pause the video and try the next questions and then turn it back on. Or check the answer key, make sure it's all good. Like I've said a whole bunch of times, there's no use just watching me do the video, right? Well, a little bit, but not much. You got to try it on your own, and even if you screw up, you're still going to get the process there. All right, next question. Matt has invested in inheritance in an account that earns 3.6 per year, compounded semi-annually. Interest rate is fixed for 10 years. He plans to use the money on the down payment for house. Okay, so we got some money. We have a percent. We have the compounded semi-annually, right? That's that extra bit we need. And it's for 10 years. Oh, ooh, look at this one. Okay, so you got to do the question twice. Once at 5 years and once at 10 years. Let's make it happen. A, P, I, N. So I got 5 years. Remember, semi-annually is 2. So in other words, every 6 months, they do the calculation, add that extra interest in. So instead of it only being compounded or a little extra added 5 times, it's actually going to be added in 10 times. But then when you do that, your interest rate with semi-annually basically gets cut in half. So 13.6 divided by 100 by 2. See? How nicely that lines up just like that. Well, it makes it a little harder to see, but that reminds you that that's the way it goes. So 13.6 divided by 100 divided by 2 equals 0.068. And he invested $23,000. He wants to know the amount at the end. I don't know who these people are that are getting all these inheritance investments. Wow. One of these days, you never know. P times 1 plus I to the N. Now let's plug it in. 23,000. 1 plus 0.068 to the 10. I was trying to look at the camera instead of looking down at the screen so that you're not always looking at the top of my head. But then I'm writing all over the place. I'm sorry, I'm not great. That's just the best it's going to be today. Pretty much for all the videos. So A is equal to 23,000, 1.068 to the 10. So we add together. Now we're going to worry about our exponent. 1.068 exponent 10. Oopsies, 10. 23,000 times 1.930. Calculate that through, and it is 44,405. Okay, 867, so 87. So in 5 years, that will have grown to $44,000. That seems really high. But I think it's okay because it's compounding and it's at a pretty high interest rate. Let's check what happens in 10 years. And if the 10-year number is less than my 5-year number, then I'll know I made a mistake up there. All right, A, P, I, N. Again, there is the open invitation for those of you that are watching the video, and if your numbers come out different than mine, shoot me an email, and let's take a look at, well, to be blunt, who made the mistake. All right, now we're looking at 10 years. It's 10 years and compounded semi-annually times 2. So we're, instead of compounding just 10 times, now we're going to do it 20 times. But 15.6 divided by 100 divided by 2. Our interest rate is also going to, wait a minute, what's going to after interest rate? I think it should be exactly the same, right? Okay. I guess I should have seen that one coming. And, okay, so this, we're not using this number. We're going back. We're going to talk about this one. When we get into the section near the end of finance where we talk about portfolios and stuff like that, you might have to do a question here and then take that answer and carry it forward. But this is saying, nope, after 5 years and the original investment, this is the same one, nothing has changed. We're just going to let it sit 5 more years. $23,000. 1 plus 0.068. And now it's going to be to the 20th. So put those together. $1.068 carat 20 this time. Oh my. 3.727 times 23,000. All right. So in 10 years, with that amazing interest rate, which if you go to the bank now, there's no way you're going to get, you might be able to get maybe 4 or 5%, but I'm going to date myself, like in, say, the 80s, you were getting this kind of interest rates, or they were charging like 20 or 25% on loans. It was crazy back then. Anyway, let's stop. Let's not worry about that, because I just really dated myself. All right. If Emma invests $1,500 at 9% yearly, compounded monthly when she was 18, how much will she earn by the time she's 65? Oh my goodness, let's take a look at this. This got all, and what is her return on investment? Remember we talked about that. Video, I think 14. Might have to go back through my notes to figure it out. Okay, A-P-I-N. Wow. So anytime that you have something with 2 dates in it, right? She does it when she's 18, and she talks about when she's 65. Okay, as I say, every time, but 95% of the time, you're just going to have to subtract. You need to know how many years that was invested. So 18, whoopsies, wrong way. 65 minus 18 is 47 years. So 47 years times month. Forgot to do my marking. 1,500, 9%, monthly, 18 and 65. Times 12. So 47 times 12 is 500. That seems insane, but she let it sit for 47 years. So yeah, that's going to be compounded a whole bunch of times. So I is 9% divided by 100, divide by 12. Equals 0.0075. Right. Again, I think I'll try and fix my calculator, but that's what you should get on yours. And it was $1,500. All right, let's see what this works out to be. So A is equal to 15. What? My bad. My bad. Formula. Please, formula first every single time. Because as we go, every time you write out the formula, it's going to be better and better stick in your head, and you're going to get used to it. And it also tells me what numbers you're putting in where. Just good practice. 1 plus 0.0075 to the 564th. A is equal to 1,500. 1.0075. Now, I don't know what that is, but I suspect it's going to be a really big number, or fairly big. 1.0075. Oh, hold on. I'll try something here. 9 divided by 100 divided by 12. Okay, see, so it's in that wonky form. If I just put plus 1, look at that. It changes it over to something I can understand. So I'm just saying you can use it like that if you want. Okay, so I got my answer. Now I'm going to do exponent 564. Holy cow. 67.64. Right? I was going to say earlier, normally this number here, less than 5, less than 10. But again, this is 47 years you let this stuff sit. So let's see what that works out to. Oh. So answer is equal to 101,461.71. So she's got $100,000 in there just by putting the money in and saying bye-bye, letting it sit. Pretty cool. I'm not sure you could actually go to the bank and get something that would guarantee you 9% per year for the length, the entire length of your investment. Often when you do an investment or something like this, what they'll do is they'll be the percent will change over years. But we are not equipped to do that. That is more of a VA problem, VA1 or VA2 or a fancy calculator. So we'll just stick with pretending it stays exactly at 9% for a long time. Look at that, a whole lot of money waiting for. All right, and that is the end of the video.